The Multi-View Visual Pipeline Programmer was developed by Team 10 for the CS CPE 426 Senior Project course as part of the 2011-2012 school year in the Department of Computer Science and Engineering at the University of Nevada, Reno. The members of Team 10 are Ray Downey, Brian Hamilton, Mike Vakina, and me, Aaron Lohr. The primary advisors for the MVP project were Richard Kelly and Professor Sergio Dascalou.
Well, Radu Rusu at Willow Garage wrote a paper describing the idea of a PPG. And in the paper, he has several diagrams illustrating the concept, and they translate one-to-one to code, but no one's built a tool that would let you do that. And having written several programs in Rusu's library, I realized that it would be really convenient to be able to very quickly prototype using a graphical language, working with point clouds and range images and 3D geometry type stuff. So
everything today that's got to be done real time, needs to be done quick, is stream processing. So we just pretty much did a visual programmer for stream processing.
Well, we've got a drag and drop framework set up so that with the plugins and the tools, we can drag them into the canvas, and you don't have to understand what's going on under the hood behind it to necessarily be able to program with it.
And you also have the ability to create your own tools and plugins, so it's really expandable to whatever you want it to do.
This is a really good idea. Nobody's done a visual programmer that's robust to current day schemes. They've done visual programmers, but once you've played with it a little while and now you've bounced off some limitation in the program, that's it. Can't do anymore. Or ours, you just create the tool, or you tell somebody to make the tool for you, and now you just continue working.
PPG stands for Perception Processing Graph. And what that basically is it's similar to what my brain is doing when I look at this object. When I look at this, my brain tells me immediately that it's a book, and I can even read it's titled Information Retrieval. What the PPG is actually doing, that perception part of it, is breaking it down into individual attributes and pieces of it. I can tell that this is green. I can tell that it's rectangular in shape, it has a depth to it, and that it has pages and things like that. So all those individual little pieces are then, that's the perception part of it. The processing part of it is taking and working on all of those, comparing green to blue to red, taking the depth and comparing that. Is this a thick book or a thin book, things like that. And then modeling all of those pieces of information and all of those little processes into a graph structure so that they're all working in concert with each other is the same kind of thing, is exactly what MVP is doing. We have all these different tools and plugins and different pieces that are put onto the canvas or internally working, and they're all working together in order to create the output stream of data.
Well, MVP in itself has these tools which are the building blocks. And then the building block itself defines, okay, here's the data that comes into it, here's the data that comes out. So it doesn't have to be a vision processing, a point cloud processing.
To tell you a little bit about MVP, it's this very complex system that we've got, right? The easiest way to explain it is to give you a bit of an analogy. Think of it, if you will, like an artist studio. Within the studio, you have all the different tools that an artist needs to create artwork. You have an easel with a canvas, you have brushes and paint and other tools that the artists use. Well, MVP is a lot like that. The paints and your paint brushes are going to be the plugins and the libraries that we use. The canvas, it's where the magic happens. We actually pull those tools over and we connect them in a PPG. And it's just like an artist canvas. That's where it all comes together.
The GUI is composed of 4 parts. The first part is the plugin library, which is essentially the list of all the plugins that is in the GUI and of all the tools that are within those plugins. And then there's the canvas, which is where the person actually creates the PPG. And the PPG is composed of the different tools that were in that plugin library, and those tools then become the nodes in the graph, and you can make connections between the tools to connect them together, so the outputs of one tool goes to the input of another tool, and you can have multiple outputs of one tool go to different tools. And then there's the command dispatcher, which essentially allows people to set the parameters that are in those tools that are created on the canvas. And then the last part is the trace, which is the output, the feedback that the program gives. So like every time you create a tool, delete a tool, or start actually running the program, it'll give feedback on how the program is running and what's happening inside. So we wanted the GUI so that people could easily use it, so that they could just drag tools onto the canvas and then make a few connections, and then bam, they have some algorithm that does whatever they wanted it to do. So that's why we chose Qt in the first place, is because it was cross-platform and rather easy to use and pretty GUI interface. I think it would be pretty fantastic if it was also used for like teaching as well, because it would be an easy way to show algorithms and let people play around with the parameters of them.
Yeah, let them see the quick results without actually having to know the math behind it, for instance.
We considered a whole bunch of different things for MVP to actually go out, control and or interface with. We talked about doing a blimp. We talked about doing a helicopter or even a quadcopter or something along those lines. We talked about even doing a tank with a paintball gun mounted on top of it that we could actually tell it where to fire and such. I think we came up with something that was pretty awesome for our use case scenario. Cost prohibitive to put a camera actually on the car, just from a hardware standpoint of the stuff of the individual pieces that we would need to transmit video, as opposed to the way we did set it up, which was put external cameras up and watch the car.
In keeping it simple, it allowed us to do more with it.
A car is a fairly simple system to be able to work with because it goes forward and back and turns left or right.
Now we can do lots of fun stuff. We can do, okay, let's try to get it to go as quick as possible. Or we can do, can we track maybe multiple cars? Can we track? These are all small extensions to that base example.
We used a FTDI interface so that we could take USB to a serial signal. And then we used the XB wireless link to act as a tunnel. And then that went into the servo controller.
The RC car has 2 signals that it expects from its stock receiver. So we had to replicate those signals exactly.
You know, honestly, exactly what I saw this morning is what I wanted to see. That whole framework of being able to drop down nodes and link them together is pretty much what I wanted, exactly. So I'm really happy.